Hi everyone. Today we're going to start a new topic, Chapter 6. And in Chapter 6, we're going to be dealing with chemical formulas and also how to calculate and do interconversion between mass of substances into the number of atoms and the number of molecules that you have for a given mass. These calculations are referred to as chemical formula conversion. Okay, so there's two things that we're going to learn: Avogadro's number, which we'll talk about very soon, and then molar mass. Okay, so before talking about either one of those things, understand a little bit about why we need to do this. So the reason why it's really hard to figure out how many atoms or molecules or ions we have is that these things are really tiny, right? So it's really not possible for us to be able to count them because they're so small and there's so many of them. In fact, if you have about 1,000,000 atoms, it's really still not visible by eye. So you really need a lot of them, way more than 1,000,000, before you can actually see them. So the question then becomes, if you have something that is so small, how do you count them? Well, we have other things in our lives that are kind of small, and we can a lot of times use the same idea that we use with those objects in order to understand how we count atoms. For example, nails are kind of small, and you want to build a new house, you want to buy a lot of nails. So let's say in this case you want to buy 5,000 nails. So you're not going to go to a hardware store and start counting 5,000 nails just because that's a lot of nails to count, and you're going to waste a lot of time doing that. So what you do instead is, and what the store has done is, they figure out the weight of one nail, and then in order to figure out getting 5,000 nails, all you need to do is multiply that by 5,000 to get the mass of 5,000 nails. So that means you can just take a bunch of nails, dump them in the balance, and see if the number is close enough to what you think the mass of 5,000 nails has to be. If you have that, then you say you have 5,000 nails. So this is what we actually do for particles also. We weigh objects that we know contain those particles, and then using the mass, we can then figure out how many particles we have. So what I'm going to do here is just do a quick example to show how this idea works with the nail, right? So the question here is, a certain type of nail weighs half a pound per dozen. A dozen is equal to 12, so there's 12 nails. And the question is, how many nails are contained in 10.5 pounds of these nails? Okay, so if you look at the information that's given, it's really just a bunch of conversion factors that you need. In the end, your answer has to have a unit of nails. So that means I'm going to need my nails to be in the numerator in the end, and the denominator to be nothing. So I'm going to start with something that has nails in them. In this case, that would be this quantity right there. So I'll say, well, I know that there's 12 nails in a dozen. Okay, and then now I need to cancel my dozen. So I'll put a dozen here. And then the other thing that has dozen in it in this information is the pound to dozen conversion. So I'll put pound right here. So that will cancel this out. Then the last thing I need is to cancel out that pound. And the only thing that's left is my 10.5 pounds. That cancels out. And if you work this out in your calculator, you should get 252 nails. Now the concept I want to get across here is really how this whole calculation works. I don't have to count 252 nails. All I did here was to know that in half a pound, which is mass, right? So notice that that's mass, or weight in this case, there is a dozen nails. So there's a certain group of nails that have a certain mass, and that group of nails are equal to a certain number of nails. So dozen becomes the conversion factor between mass and number of nails. That's important because not everything is going to be counted as a dozen, right? So for example, you might have heard of this unit called a ream, which is equal to 500 sheets of paper. In the cases of papers, for example, you're not going to use dozen to make your conversion. You're going to use ream. So I don't necessarily need to count these little things like nails. What I can do is just use these group units that relates to the mass of these tiny objects, and from there I can go ahead and actually figure out how many nails I have. Okay, all right, let's move on now to how we do it with particles. What we're going to do is we just need to find the same kind of group unit that we used for nails earlier. In nails we use a dozen. For particles we use something called a mole. It serves the same function like that dozen, which is that in one mole there's a certain number of particles. specifically, in this case, there is 6.02 times 10 to the 23rd particles. Okay, so a mole is just a unit, a group unit, just like a dozen, except that in this case, there's a lot of stuff in a mole. So if I say I have a mole of marble, really what I mean is I have 6.02 times 10 to the 23rd number of marbles. Why do we need such a big number? Because atoms are really small. You can't really see them. You need a really big number before you can start seeing them. Okay, and so for example here, 22 pennies actually contain exactly 1 mole of copper atoms. So you can see that 22 pennies is not a ton of pennies, but if you can look at the individual copper atoms in the pennies, you'll find that there's a mole of copper atoms in them. Okay, so let's go on now to thinking about how to use this in calculation. We can use that as a conversion factor, just as we did earlier with that dozen. So we can write that 1 mole is the same as 6.02 times 10 to the 23rd. Now, what's the unit at the bottom here? Well, as you'll see later on, it could be anything depending on what it is that you're dealing with. Right now, we're just going to say atoms. So that would be one way to write that conversion factor, or you can write it as 6.02 times 10 to the 23rd atoms per 1 mole. So if you want to convert between moles and atoms, all you need to do is use this conversion factor. So let's take a look at this problem right here. Just how many gold atoms do I have in a ring that has 8.82 times 10 to the minus 2? So all we need to do here is just do a little calculation with the conversion factor. So we're given 8.83 mole times 10 to the minus 2 mole of gold. To cancel out, so we're going to write mole at the bottom. And then in the top, we're going to write the number of gold atoms. And so in this case, we have 1 mole equals that number, 6.02 times 10 to the 23rd. So if I go ahead and multiply this in my calculator and rounding to the correct number of significant figures, which is 3 in this case, I should have 5.32 times 10 to the 22. And what unit do I have? Well, the mole of gold cancels out. And so what we have is a unit that's just gold atoms. Hopefully that makes sense, how we convert between number of particles and then moles.